Hello there, students. Welcome back to our maths class. It's so nice to see so many of you today, and thank you for being here. Good. Now let us move on. As you can see on our screen today, what is it we'll be doing? Right, reflection. Good. Now to begin today's class, I have a little activity cut out for you. All right? Let's get down to it. Good. So I've given you 5 images, all right? I want you to observe these images and see if there is any reflection in it at all. But before we do that, do you know what is the reflection? Let us find out what is the reflection before we do this activity, all right? Look at this mini vid.
That's the reflection. Let's talk about symmetry, okay? Flip the shape, what's the first one? Symmetry. Reflection.
All right, so that video there tells us a flip is a reflection and it happens across a line of symmetry. Good, so I want you to use that information given there that a flip is a reflection and see if you can find any reflection in these pictures for me. All right, you got 2 minutes. All right, your time is up. Yes, Jack. What do you think about the Jamaica flag? Do you see any reflection happening there in the flag? Right, Jack. You see that the left side of the flag is being reflected to the right side. So when you fold that flag in half, you get a line of symmetry there, isn't that so? Right, so everything that is on the right side is on the left side. So we could see a reflection happening there. All right, good. What about the Taj Mahal, Mary? What you notice? Any reflection is there? Yes? Right, you're correct. So where is that reflection? Good, that reflection there is in the water. So where do you think that line of symmetry will be? Right, you're correct. It's going to be between the Taj Mahal on the land and the Taj Mahal in the water, like that line of land there that you see. Good, so when you fold it in half, the line that you get there is going to be your line of symmetry. Everything that is at the top is going to be at the bottom. All right. What about the ambulance there? Why did I even put that ambulance? I don't see a reflection. Right. The words are being reflected. I like that, Janet. I like that. So what happened to the word? So you're telling me the word is written back to the front. And when you look through a mirror, a rear-view mirror when you're driving, you see the word correctly. All right, let's take a pin name. Now, if you observe the ambulance, right, when you're on the road, you will notice the word that is back into the front on it. Good. Now, that is to help drivers when they're watching the mirror, they could see that it is an ambulance coming from behind them. So they are going to see the correct way of how the water should be. So yes, that is how a reflection is being used when you're driving on the road in terms of the word and the mirror. Right. And do you see any changes there with the words? No, the shape and the size remain the same. It's just the order of it, right? Back into the front and forward. Right, you guys are good students. Now, what about the mountain? Any reflection there? Right, at our top and bottom reflection. What do you mean by top and bottom? Right, the mountain on the land is being reflected in the water. So if you fold that picture there in half, you will see where the line of symmetry is. Good. Now, you all have been telling me left to right or across or up and down. Now, let us go back to our coordinate plane, right? We know that the line that runs up and down, is our y-axis. But what is that line that runs from up to down or down to up? Correct, your vertical line. Good. And what about this one here? The one that runs across is our x-axis, and that line is also called a horizontal line. Good. So looking at these pictures here, what can we say about reflection? Using the word horizontal and vertical. Yes, Mary, you got it. We can say a reflection can either be vertical or horizontal. Very good. For example, the Taj Mahal, it can be a what? A horizontal reflection or a vertical? You tell me. When it flips from top going to the bottom, we can say it is vertical. It goes up, down. When it goes across, we say it is horizontal. Right, right. Now let us move on from this. So we established what is the reflection and the two types. Now let us pinpoint what we have learned so far from the video and that activity. We can say that all the points of an object are reflected or flipped on a line called the axis of reflection or the line of reflection, right? Now, when we talk about that, as shown in the video, we could have seen that that a flip, it happens across, and the line there is called your axis of symmetry. Well, that is what we mean by your axis of reflection. So a reflection is defined by your axis of symmetry or mirror line. So under our reflection, as we talked earlier, the shape and the size of the image will be the same as the original shape. And this type of transformation is going to call an isometric transformation. Why? Because you flip it over and the shape and size will remain the same. All right, students? Well, as we already established that reflection occurs in two ways, that is horizontal and vertical. Let us look at the horizontal reflection, all right? Good, and we know the horizontal reflection, we already identified, it occurs in your x-axis because the horizontal line on our coordinate plane is our x-axis. Good. Now I want all of you to get a piece of graph paper, all right? And I want you to drop the coordinate plane to 5 units on each axis. Good. After you would have done that, you fold it horizontally, right? You fold it horizontally. Good. Fold it horizontally on your x-axis there. Good. All right. Now I want you to anywhere punch a point on the paper. All right. Punch a point on the paper, any point. Do that quickly for me and tell me what is it you noticed when you open back the paper. All right, so I fold my paper horizontally. All right, so I went on my x-axis and fold it horizontally. Then I look for a coordinate. So I choose the coordinate -2, 1. I'm sure you remember how to plot your points. So I went to -2, 1, right? And I punch a point. So I punch it through the entire paper that I fold. And when I open it back now, where I punch will have a hole somewhere. Right? Remember when you fold it in half, you're punching it through the nether half as well. So when you open it, you're going to get your reflection point. Why? Remember, it is a flip across or along the axis of symmetry. Or we can say along the x-axis because we would have folded horizontally and we just punch a point through the paper. And when we open it, we can see that that point, it flipped across. It flipped from where I punched it to the bottom here of the x-axis. So let us look at that coordinate. So I punched at -2, 1, right? So we say the object there, yes, we give it a name. The object, that is the point you place, is -2, 1. All right, good. And our image, yes, the point that you are reflecting, right? You're going to get a new point when you open your paper to see where the hole is. So that there is going to be our image point. So reflection now, it works with object and image. Good. So we say the object is -2, 1, where I punched. -2, 1. And what is going to be our image now? When I open back my paper, I find the punch at -2, -1. All right, I find it at -2, -1. So looking at these 2 points, our object was -2, 1. And when we reflect it, we get -2, -1. What did we notice about those 2 coordinates? What do we notice about our X and Y coordinate when we reflect it? You tell me. Let us come up here with a rule rather than fold the paper. Right, Ravindra. You see that what? The Y coordinate changed. Why? How did it change? From a 1, it became the -1. Right? Did anything happen with our X coordinate? No. So that is why when we are reflecting -2, 1, right? When we are reflecting our object point -2, 1, we get -2, -1. Because according to the paper, when you fold and punch the point and you open it, you end up at -2, 1. And we can come up with a rule there for when we are reflecting in the x-axis or we are reflecting horizontally. It means that our x value will remain the same and our y value will change. From a positive, it becomes negative. What happens? From a positive, it becomes negative. So as shown in this example, we have -2, 1, which is our original coordinate. When it is mapped on to the, when it's reflected, it becomes -2, -1. So in reflecting in the x-axis, we know our coordinate changes. That is our y coordinate change from a positive to a negative. All right, let us look at B. B is 1, 4. B is 1, 4. So we go on our same paper that we were folding. We go to 1, 4. Then we fold it. We punched where that point is, right? And then we open our paper to see where that hole or reflection would be. And we get, what did you get, Mary, when you punched it? You get what? You get the image is 1, -4. All right, let us see if that's true. So we say the rule is that the y coordinate changes from a positive to a negative. Good. So B is 1, 4. So our image coordinate will be 1, -4. So yes, you are correct. Let us look at C now. We go back on our paper and we plot 2, 3. 2, 3. Right? And then we fold our paper and we punch it through. We punch it through and let us see what we get, Jack. What did you get? 3, what? 3, -2. Correct. So do you see we establish a rule there? When you open, when you put the point and then you fold it horizontally and you punch, you get the coordinate. Right, so here our rule in reflection in the x-axis, we get it as the x coordinate is going to stay the same and the y coordinate is going to reverse, or we say it changes from a positive to a negative. All right, so please take note of that. Good. Now let us look at the vertical one. So we're going to use the same technique. All right? Good. So we're now going to fold our paper vertically. So remember we established earlier when reflecting in the vertical line, we are basically reflecting in the x-axis because the vertical line is the when we are reflecting in the vertical line, we are reflecting in the y-axis because the vertical line is the y-axis in our coordinate plane. All right, is that clear, students? Good. Now, we know reflection is a flip, right? So we're going to flip across the y-axis. Good. So we know the rule in the x-axis is that the y-coordinate changes. Let us see what is going to be a rule here. So our first coordinate is that on our paper, using the same dimension of the coordinate plane, where you have to drop 1 for 5 units, we're going to use that same technique again, right? So I want you to plot the point 1, 3. So point A is 1, 3. So we're going to fold our paper vertically to suit our y-axis. Then how far we plot our point A, we're going to punch a hole through, all right? And when we're done, we open our paper and we see where that hole falls. And where it falls for you, Mary, 1, 3 is what? When you reflect 1, 3 in the y-axis, what you get? -1, 3. All right, so that is going to be our image. So our object point was 1, 3, and our image point is -1, 3. All right, let us plot point B. All right, let us plot point B. Point B is 5, 2. So plot 5, 2 on your graph. Then you fold it vertically and you punch a hole through 5, 2. Right? And let us see what we get. So according to the hole, we get -5, 2. Isn't that so, Ravindra? Or 2, -5? What you got? Right. It's -5, 2. All right. Let us punch point C now. Point C is 4, -1. 4, -1. So we fold our paper and punch the point. Let me see. Right. When you punch through, what do you get, Jack? -4, -1. Right. Now I want you to observe those coordinates punched. All right? Observe it for me. And tell me, for number 1, when we punch 1, 3, 1, 3, and according to our reflected point, what did we get? We get -1, 3. All right? So tell me, what is it you notice about these two coordinates? We can see that the y coordinate remains the same because they're both in the same line. They're both in the same +3. But if we look at the x-axis, we will see the object from a +1, it becomes a -1 when we reflected it in the image. Isn't that so? So therefore, we can conclude and say that when we are reflecting in the y-axis, that the y-coordinate remains the same and the x-coordinate is changed, meaning from a positive, it becomes a negative. All right, students, so you get the concept there. So when we are reflecting vertically, or we are reflecting in the y-axis, we know that y-coordinate remains the same and the x-coordinate changes, or it is reversed from a positive to a negative. But let us say it is negative, right? If it is negative, it becomes a what? A positive. When we say reversed, it means if it is a negative, it becomes a positive. And if it is a positive, it becomes a negative. All right, good. Now I have an activity here for you, an exercise. Now to do this exercise, I want you to log on to our GeoGebra app where I can see you work. So you're going to work this exercise and you're going to share it to me so I can see how well you're doing with graphs. Okay, so come on quickly, log on to our GeoGebra app and let us start working these two questions. You have 10 minutes to do so, okay? So good. Now, after that exercise there, I trust that you all would have understand what is happening with your X and Y coordinate when you are plotting points. Now, I want you to understand that when you are reflecting points in the X coordinate remains the same, and the Y coordinate, you change it, or what we say is that we change it from negative to a positive or a positive to a negative. So remember, your X coordinate is the same and your Y coordinate changes when we're dealing with reflection in the X axis. And when we're dealing with reflection in the y-axis, we know it's going to be the opposite. Your y coordinate will remain the same and your x will change. So is that clear? Any questions? I trust that over this course, you would have noted down at least 2 questions you would want to ask me. All right? So I am here ready to listen to your questions that you would have noted down during the course. Now, while you are thinking about those questions, I want you to remember that you are always given homework and I want you to work it, all right? Remember, more practice, the better you are at it. Isn't that so? Good. So for your homework, I want you to draw a picture showing reflection in your home. And when you finish, you're going to use that same picture and you're going to place it on your coordinate plane and you're going to reflect it in the x-axis. All right, good. Then you're going to have to do another question. This one here is stereotically where you have triangle PQR has coordinates -7, 3, -5, -5, and -3, -2 respectively. And you're going to reflect this triangle in the y-axis. All right, good. So now I'm ready to listen to all of the questions you have had for me. Right, remember you had to write down 2 questions to me that you would have had. So I'm ready to listen for it, okay? So I understand none of you are not having any questions. All right, well, I have a question for you. All right, so when do we use reflection in real life? I think we mentioned that previous in the class. So name one situation for me where we can use reflection. Right, Mark, we could use it when we are driving as drivers. We're using our mirrors to reflect what we are doing, isn't that so? To reflect the car, the number plate, the roadside, so we can know where and how to drive, isn't that so? Right, Mark, round of applause. Now, what do you think is a reflection, Mary? Right, a flip across along an axis of symmetry, and we call it a line of reflection. Yay, that's wonderful. Yes, Jack. And when we are reflecting in the x-axis, what do we do? Right, you are correct. We let the x coordinate remain the same and we just trouble the y coordinate. Is that we change it from a negative to a positive or from a positive to negative. So you students are brilliant. I thank you for being a part of today's class and I expect you to be more interactive in our next class as well as you do your homework. So thank you once again. All the best. Enjoy your week. Bye.